Hello, this is Clayton Balmas, and I'm your audio teacher here today with SynMax University, available here at synmaxperformancelubricants.com. Today we're going to be talking in part 3 of our multi-part series of racing and coolant commercial systems. Part 3 is going to be broken up into two areas, which is water and then coolant system cleanliness. So everybody says, does water really make a difference? Yes, it does. So I hope you enjoy listening to this as I enjoy sharing it with you. So let's go for a ride. Water chemistry performs best within a 7.0 neutral and pure environment. You see, when a coolant treatment, chemicals do not have to work and fight against the contaminants within a high mineral environment is found in ordinary tap water. The chemistry is able to freely operate 100% to function as originally designed. If a coolant treatment, or this goes for any water chemistry that is used with regular tap water, hard or high mineral contact water, the chemistry efficiency will be reduced up to 30%. Now, if this is reduced 30%, it will affect the heat transfer, acidic, corrosion, electrolysis control, and other capabilities of what the chemistry was trying to do. That is why you should use 7.0 neutral, balanced, purified water to provide a clean, mineral-free environment. We're going to get into that now. You say, why is that so important, Clayton? Because I've seen firsthand under the development of the chemistry that we're going to have here that if the water balance is off, it affects so many variables. So instead of having to fight the minerals, just don't have them. Now furthermore, you'll have some chemistries that will say, well, you can use this with tap water or you can use this with hard water. Well, you could use SynMax water cooler treatment with hard water and tap water too. Doesn't mean it's going to work better, but you can use it. You know, something's better than nothing. But wouldn't it be better if you didn't have problems come into your neighborhood in the first place? Just think about it. So let's continue this thing on the purified water. One of the keys to coolant and chemistry success is clean, acidic, electrolyte, and mineral-free or greatly reduced mineral and electrolyte-free 7.0 balanced neutral environment. You do this when you get rid of the micro liquid salts. Now, salts can be more than just salt. I mean, it's a variety of minerals, okay? In the water, further explained within this presentation. You're going to like this. Here's an example. Clayton, how do I know this works? Well, it's like this. You see, when you boil your water, all right, let's say you want to boil some pasta water. You always talk about pasta. Well, you know, there you go. But when you boil your water on your stove, just tap water, all right, that's just off, you know, from the ground, tap water, whatever, you'll notice that salts are released at about 125 degrees. And then they stick to the side of your pan, all right? And that is what also happens in your coolant system. So if you want to have that type of contaminant sticking onto your, you know, expensive block heads and radiator that you spent many thousands of dollars for, if that's the type of chemistry that you want, then just use your tap and hard water, right? Go right ahead. But if you want to protect your business model and investment for a few dollars and performance repeatable efficiency, well, we've got an answer for you. Now here's what happens chemically. Salt is naturally acidic, all right? It also means it's a corrosive. And without chemistry protection, in time, it will attach to all the materials that it comes in contact with, which is the steel, the iron, the aluminum, the rubber, the gaskets, and everything. Salt naturally, because of these minerals, all right, the salt naturally carries what we call the electrolytes into the water. Now, when we have a neutral, purified environment, these electrolytes are greatly reduced. There's still some in there, but they're like, 90% cut out. But we have to remember the salts and the minerals in the water is very dangerous because it's going to create electrolysis, which we'll get into in a future presentation. But this salt combination will create an acidic, corrosive environment like electricity in a battery. It will create a slow surface destruction of all coolant system and radiator heat exchanger components. Furthermore, if you have these minerals in your water and then you have expansion and contraction that takes place between the gasket material of the cylinder head and the walls, right? These small salts and minerals, when they get in there, they will then attach to the iron or the aluminum. And then when they get hot and they expand again, and then those minerals get flushed out, they'll take a little itty bitty micro piece of the aluminum or the steel with it. Now, initially, that's not going to cause a problem. But when you've got your center cylinders that are the hottest, especially on the exhaust side, all right, I'm going to guarantee you in time that it's going to affect your gasket performance. And in the extreme heat in extreme duty environments, in a racing environment, we just don't want any problems in the neighborhood. Hello? Well, let's go on. We must understand that in a racing high performance extreme duty environment, that when we increase the RPMs, like from a street car from 2,000 to as high as, let's say, 9,000 RPMs, the chemistry affects triples and quadruples even faster. So we have to have even a more advanced chemistry in an advanced extreme duty condition. So as I said, if you start out with a bad situation, it gets worse quickly, I promise. What's the solution? The neutral purified water with the right chemistry. Now, what we want is a treatment should also lubricate and provide maximum protection for the water pump bearings. Furthermore, if a treatment already has the exact amount of product in it, you don't need to put 2 bottles in. All right? I'm going to be straight with you. I asked a person one time, why is there so many tens of thousands of bottles of this one competitive product being sold? I said, why? To a major engine builder. He says, you know why, Clayton? I said, why? Because they got to use 2 bottles to make it work. I said, you got to use 2 bottles? Yeah, because it's so watered down, they got to buy 2 bottles of it. I said, wouldn't it be smarter if they just made 1 bottle with all the chemistry maximized to what it had to do? They said, yeah. I said, well, here you go. I thought that was funny. But the other thing that you have to have is a water chemistry with a little bit of molybdenum in it to protect the water pump bearings, all right? And another chemistry separate from that is a seal conditioning chemistry. Now, the seal conditioning chemistry will help the hoses because they're rubber and the seals around the water pump bearing. Because if you use straight water without this, especially in drag racing or whatever, I'm buying water pumps all the time. Well, if you use this chemistry, you don't have to worry about it. Now, here's another common myth. They think glycol, because it feels slippery, has lubrication properties. No, it doesn't. Now, it might be slicky, but it doesn't have lubrication properties. Actually, glycol has very little lubrication and does not provide sufficient protection for your water pump. Okay? You need to have the seal conditioning and water moly chemistry that's in a system treatment such as the water cooler. Because here's the reason. As I mentioned, the water moly, okay, coats and protects the water pump bearing surfaces, and it also reduces the coefficient frictional drag upon the bearings, enhancing water pump performance. See, when you historically on dynamometer testing, when you use this chemistry in the coolant system, it will reduce the drag upon the water pump, I believe, about 1 horsepower. Okay? Now here's the situation. Water pump component life is increased when the bearing, shaft, seals, and rubber areas are protected and conditioned. And that is the chemistry science choice that is put into the water cooler product. Now, as we mentioned, the water pump requires an advanced water molecule chemistry to protect it and for the hoses. Now, here's something else I had to throw in. Recently, within the last 5 years, the solder, because of the environmental safety, they pulled the zinc out of the solder. All right, we don't want any more zinc because it's bad for the environment. Well, when they pulled that out, it also made the solder porous and not as strong and as good. If you have an acidic environment within the coolant system, it will attack the new solders. Now, a lot of the radiators that are coming in from other countries, such as China or whatever, they don't have the higher grade or use enough of the solder. And it has been proven that if you do not have the right chemistry within the water, it will go through the micron pores in the solder, and it'll eat right through onto the edges or whatever, and it's a bad deal. Okay, so if you've got a brand new car, or you have a concern on this, if you put this water cooler chemistry inside of it, it will help reduce the acidic environment, coat the aluminum, coat the solder, so that it'll help give that little extra layer of protection. But I just thought I'd throw that in. Now, clean water will also help the boiling point elevation. You see, treatment doesn't significantly increase the boiling point of water. All right, heat transfer efficiency and fluid pressure does. Okay, increasing coolant system pressure will raise the boiling point. Why? Because the pressure will force the bubbles against the surface of the metal and the coolant system. Now, historically, when you use the water cooler, the chemistry will increase the heat efficiency up to about 230 degrees. Okay, and which is great. Uh, the only thing I can say is when you come in off the track, all right, what that means is this: is that if you're racing and you get into a heat soak on a slow lap, the caution's out. If it goes up to 230, don't worry about it. You don't have to turn the fans on yet. If it creeps past 230, think about it. And then as soon as you start moving, then the air will come past, and then you'll have greater heat transfer efficiency. Another thing I want to throw in is if you do have a fan, do not have it on the front of the radiator. Have it on the back side of the radiator. Try to reverse the polarity to pull, not to push. Okay? Because the problem that happens with the fan is sometimes it will just create a big wall. It really won't pull. All right? So what we found out is just, on your short track cars, just to have a little itty bitty, fan bolted onto the water pump, it works well. The key here is we have to have the air passing through. Now, if you come in after a session, just don't shut the car off if it's at 230 degrees, okay? Try to let it settle itself down, or else you're going to have a heat soak push out because, there you go. But in general, you can run at the 230 degrees safely, all right? And as long as the engine is properly circulating the coolant through the block and heads with sufficient area through the radiator, you're not going to have a heat soak boil over. All right? And that's historically what we found. If you want a simple pour and go system with the purified water and the exact chemistry that's already in there, we encourage you to use our SynMax water cooler premix. For racing, it's a direct 100% use. In all weather, you can be able to have 1 gallon of water cooler to 1 gallon of glycol, and there's no additional treatment needed. Yes, and that's for your diesel truck or your standard automotive, commercial, or personal applications. Furthermore, a very good consideration for your turbocharger and supercharger intercooler fluid requirements and needs. So here we are at the end of our presentation. It's going to be A, which is on Part B. We're going to be getting into coolant system cleanliness in Part B, which is to be continued. So again, we encourage you to listen to our other presentations that we have here on the internet and within the web. So this is Clayton Balmas here with SynMax University at synmaxperformancelubricants.com, and we look forward to seeing you at our next session.